Welcome to The Explainer. Today, we're diving straight into some truly fascinating source material. Chapter 1, A Day at the Beach. Now, on the surface, this might just look like a totally standard, simple kids' textbook chapter, but we are going to look a little closer and uncover this brilliant, hidden pedagogical journey that's happening right under our noses. We'll see exactly how it seamlessly takes young minds from the purely physical act of counting all the way to the highly abstract concepts of modern math. It is surprisingly genius.
So, think back for a second. Do you remember the exact moment you actually learned how the number 100 works? For most of us, honestly, that memory is just a complete blur. We know how to use it now, but that initial aha moment of really understanding place value and base 10 systems is usually totally lost to time. What is so captivating about this chapter is how it deliberately and meticulously constructs that exact light bulb moment from scratch. It doesn't just hand the student the rules, it literally makes them build the rules themselves.
All right, let's jump into part 1, A Day at the Beach.
Every great educational journey needs to start in the real, tangible world. We start off by looking at this vibrant, kind of wonderfully chaotic beach market scene, which acts as the absolute perfect hook. Before throwing out any scary, abstract numbers, the text just presents familiar physical objects. You've got coconuts hanging by a stall, bunches of bananas, brightly colored balloons held by a vendor. It grounds the entire learning experience in a real-world scenario that feels super approachable.
And right off the bat, the text challenges the learner with this extremely direct question. How did you count them? Did you count them one by one, or in bunches or groups? This isn't just casual conversation, right? It's a highly calculated cognitive nudge. It prompts the learner to instantly realize that tedious one-to-one counting is incredibly inefficient. It basically hacks the brain's natural desire to find shortcuts and look for patterns.
Which brings us to section 2, the power of grouping.
Okay, so once we realize counting in bunches is way faster, we have to intentionally organize those bunches, and that is the foundation of our entire number system. We see this exact transition perfectly illustrated here. On one side, you have these scattered, disorganized, loose shells that take real, frustrating effort to count. But on the other side, those exact same shells have been beautifully strung into organized necklaces of 10. Your brain can process that second visual almost instantly, can't it? This leads us right to the core definition of grouping, systematically organizing individual concrete objects into consistent sets to make counting faster and easier. The text uses this really relatable story of a girl named Serbi helping her mother make bracelets and necklaces out of shells to introduce the concept of base 10. Notice what's missing here? There are absolutely zero complicated formulas. It introduces the core mechanics of our mathematical system through a simple physical craft activity so the student never feels overwhelmed by abstract rules.
Moving on to Section 3, Making 100.
This right here is the absolute climax of the chapter's teaching arc. It's the exact moment physical grouping transforms into a genuine understanding of place value. And it does this through a super energetic game called Let Us Make 100. The rules are simple but honestly brilliant. Players roll 2 dice, collect that many loose units from a bank using everyday items like little Rajma beans, and whenever they get 10 units, they must exchange them for a single 10 strip from the banker. By physically trading these small items for strips, children are quite literally holding the mechanics of place value in their hands. They're feeling the exchange rate of our number system way before they ever have to write a single equation down.
Next up, section 4, number riddles and logic.
Once that physical foundation is rock solid, the chapter just pivots incredibly fast into a realm of pure mental abstraction. It gamifies the logic with a series of who am I riddles. Take a look at this one. I am the smallest 2-digit number with 3 at the tens place. We aren't counting physical beans anymore. This is challenging the learner to manipulate the concepts of tens and ones entirely inside their own head.
And boom, the answer, of course, is 30. To get this right, you can't just rely on rote memorization. You really have to have a genuine internal comprehension of exactly how place value dictates the size and meaning of a number.
Let's step it up a notch and look at another one. Slightly harder this time. I am the largest 2-digit number where no digit is repeated. Now this is cool because it forces the student to recognize and apply multiple constraints at the exact same time. They have to know size, sure, but they also have to pay attention to a highly specific rule that totally overrides their first instinct.
So the twist answer here is 98. I mean, a student's first instinct for largest 2-digit number screams 99, right? But 98 takes the win because of that no repeat rule. And this is just a masterful way of blending basic math with critical reading and logical thinking. It absolutely keeps the learner engaged and on their toes.
Finally, we hit Section 5, Math in the Real World.
The authors clearly know that abstract math is completely useless if it stays abstract, so they very carefully pull all this knowledge right back down to earth into practical life. By introducing an August calendar, they're teaching children a totally vital lesson. Numbers aren't just for counting coconuts or solving logic riddles. They are the actual tools we use to track time, plan our lives, and organize significant cultural events like Independence Day, Onam, and Raksha Bandhan. Numbers literally give structure to our shared reality.
We also get this charming little illustration of kids talking about their favorite cricket player. Why include this? Because it beautifully demonstrates the concept of numbers as identity labels. Whether it's your house number, your roll number in class, a train number, or jersey number 17, numbers serve as unique identifiers in everyday society.
And the chapter concludes with this deeply poignant historical note. It reminds the reader that the beautiful way we write numbers today, utilizing the digits 0 and 1 through 9, originated right in India. It beautifully roots this entire incredible mathematical journey in a profound sense of cultural pride.
We've seen how a single chapter takes a learner from counting coconuts on a beach to manipulating abstract logic and tracking the calendar. So I'm going to leave you with this final thought. If a simple chaotic beach scene can be used to seamlessly teach the foundation of all modern mathematics, where else is the magic of math hiding in plain sight in your everyday life? Look around you. The numbers are everywhere, just waiting to be unpacked.